Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P2229, represents a high-voltage condition in the BARO, barometric pressure sensor circuit of the Honda Civic models from 2011 to 2015. This error suggests that the readings from the BARO sensor, which is responsible for measuring atmospheric pressure, are outside of normal operating parameters. The BARO sensor plays a critical role in the vehicle's engine management system by providing essential data to the Engine Control Module, ECM, for air-fuel mixture calculations. Its accurate functioning is vital for optimizing engine performance, emissions control, and fuel efficiency. The location of the BARO sensor is typically within or near the intake manifold or throttle body, depending on the vehicle configuration. It's important to address this error promptly to prevent potential engine performance issues that may result from incorrect pressure readings. The BARO sensor is designed to monitor the atmospheric pressure, feeding crucial information to the ECM for optimal engine performance. When the code P2229 is triggered, it indicates that the readings from this sensor are registering unusually high voltage levels, specifically above 4.49 volts. Consequently, the sensor's readings may lead to erroneous data being relayed to the ECM, potentially causing improper air-fuel mixture adjustments. This can adversely affect engine performance, leading to several symptoms that may make the vehicle less efficient or even cause drivability issues. The BARO sensor is usually positioned within the intake manifold region, making it crucial for assessing the engine's intake air features. Given its centrality to engine function, troubleshooting this sensor is essential to restoring optimal vehicle operation. There are several possible causes for the DTC P2229 to occur, and understanding these can guide effective troubleshooting. A common culprit is a faulty BARO sensor itself, which can fail due to wear and tear, corrosion, or manufacturing defects. Another potential cause is damaged wiring, which may include frayed or short-circuited wires affecting the voltage supply to the sensor. Additionally, the ECM may sometimes malfunction, potentially due to outdated software that fails to properly interpret data from the BARO sensor. It's crucial to rule out these components and connections systematically during diagnosis. The integrity of the electrical supply and the sensor's condition must be assessed to pinpoint the precise cause of the high voltage reading. This comprehensive evaluation ensures that the correct repairs are implemented, thus restoring vehicle functionality. When the DTC P2229 is triggered, several symptoms may manifest, indicating potential issues with the vehicle's operation. Drivers may notice degraded engine performance, which includes a lack of power during acceleration or an uneven idle. Additionally, reduced fuel efficiency could occur due to incorrect air-fuel mixture ratios caused by erroneous data from the BARO sensor. Drivers may also see the illumination of the check engine light on the dashboard, prompting further investigation into the issue. These symptoms collectively suggest that there is a malfunction in the BARO sensor circuit, making it essential to promptly address the DTC to prevent further complications. Awareness of these symptoms can help in taking preventive measures before more serious issues arise, ultimately leading to costly repairs. Proper vigilance can make a significant difference in long-term vehicle health. The first step in troubleshooting the P2229 DTC involves verifying the problem by turning the ignition switch to the on position. This action powers the vehicle's electrical systems and enables diagnostics to take place. After doing this, the next step is to check the BARO sensor readings through the Honda Diagnostic System, HDS. You should specifically look at the values returned for atmospheric pressure, checking if it indicates about 160 kPa or above 4.49 volts. If the readings confirm high voltage, this indicates that the failure condition has been duplicated. However, if the values are within normal ranges, the issue may be intermittent, showing the system is functioning correctly at that moment. Recording this data is crucial for understanding the extent and nature of the issue and can guide subsequent troubleshooting steps effectively. The second step involves checking for pending or confirmed DTCs using the HDS. This step is integral in determining whether DTC P2229 remains indicated or if other issues have surfaced. If the DTC is indeed confirmed, it is essential to inspect for poor connections or loose terminals, specifically at the ECM, or Engine Control Module. Because the ECM interprets the BARO sensor's readings, any faults in its connection could cause misleading readings or system malfunctions. If the ECM has been updated recently, it is also wise to substitute it with a known good unit for further verification. If any issues persist after substitution, you may need to revert to the initial troubleshooting stage for a thorough review of all components involved in the BARO sensor circuit. Proper assessment is vital to ensure that the vehicle operates efficiently and safely, avoiding potential unnecessarily costly repairs. Final repair verification is a critical stage in the troubleshooting process for DTC P2229. After completing the necessary repairs or component replacements, it's essential to check for any pending or confirmed DTCs once again with the HDS. If DTC P2229 is still present, it indicates that the repair has not resolved the issue. In this case, further investigation is needed to identify underlying problems in the BARO sensor circuit. However, if the code is cleared, confirming successful repairs is vital, which may involve ensuring that the connections and terminals at the ECM are secure and functioning properly. If the ECM was originally substituted and the issues persist, the original unit should be replaced back. Such thorough verification is key to ensuring the vehicle is fully operational and safe on the road, thus restoring confidence in its performance. Implementing preventive maintenance can significantly reduce the chances of encountering DTC P2229 or similar issues in the future. Regular diagnostic checks using the HDS can help to identify problems before they evolve into serious faults. Additionally, routinely inspecting the wiring and connections related to the BARO sensor and ECM ensures that any corrosion or damage can be caught early. It is also advisable to stay updated with any software upgrades for the ECM, as outdated software can lead to misinterpretation of sensor data, including that from the BARO sensor. These proactive measures help to maintain vehicle efficiency and performance, ensuring longer service life. Moreover, keeping a detailed log of any diagnostic trouble codes and corresponding fixes can assist in tracking recurring issues, providing a clearer understanding of the vehicle's health over time. In conclusion, understanding the role of the BARO sensor and its importance in engine performance is essential for effective vehicle maintenance. The troubleshooting process for DTC P2229 emphasizes systematic steps to isolate the issue, ensuring that no redundant checks are performed. From verifying initial symptoms, checking diagnostic data, to the eventual repair verification, conducting a methodical approach helps in accurately diagnosing the problem without unnecessary replacements. Furthermore, integrating regular preventive maintenance practices can greatly reduce the probability of future errors, enhancing the overall reliability of the vehicle. By keeping these key points in mind, Honda Civic owners can significantly improve their driving experience and ensure the engine operates at peak performance. Following this guide empowers technicians and car owners alike to tackle DTC P2229 with confidence and efficiency. Please like and subscribe to the channel. See you next time.